Eventually, every database person runs across a query that turns out to be more like two queries. The question is, how do you put them together? The answer is a subquery. This is a really useful solution to a lot of things that look like they're really, really difficult to answer, but a subquery makes them pretty easy. It's a great tool to have in your SQL arsenal. So let's get started and take a look.
Subqueries are really just a way to combine two queries into one. And so it's kind of a query inside a query. As soon as you start to recognize the questions that are best answered by subqueries, you'll start to see them everywhere. So here's one good one. Which other plays were written by the author of Hamlet? Well, you might know who wrote Hamlet anyway, but if you had to look this up in the database, you really need to do this as two separate questions. First, you have to figure out who wrote that play. Well, we know it's Shakespeare, but still, if you had to look it up, you have to figure out who that person is. And then once you have that answer, you can ask the second question, which is select all the plays where the author equals, blah, 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 William Shakespeare. And so it's really a kind of a two-part query, right? All kinds of them. Like here's another one. Which other states joined the U.S. the same year as New York? Well, first you've got to figure out what the heck year New York joined the States. I want to say 1788, but I can't, it doesn't matter. And then once you know what year that is, then you can ask the database, right? Select all of the other states where the year equals blah, 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 blah. Here's one. Which birds were seen by the person who saw the most Baltimore Orioles? Same thing. First, you've got to count up how many Baltimore Orioles everybody saw, figure out who's the winner of that contest, and then ask which other birds they've seen. And we're going to do that one actually here in a couple of minutes, so stay tuned for that. Here's just another one. We're not going to talk about this, but like how many Super Bowls have been won by quarterbacks who had previously won a Super Bowl with a different team? Well, first you've got to figure out all those Super Bowl winning quarterbacks, and then you have to do another query to see if they've played with a different team and whether they, et cetera, et cetera, et cetera. So it gets to be a little complicated. But this structure of these kind of two-part questions, but could be more, could be three-part, four-part. These really complicated questions are perfect for subqueries. Now, in the long run, there are actually three different ways to solve this problem. We're going to look at each one of them actually in this lecture. The first is the idea that we just saw, and we're going to do this in more detail in just a moment, which is actually do two separate queries. So you'll have query number one, which is a select blah, 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 blah. Query number two, select blah, 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 and then you can combine those two answers. The main focus of this lecture, though, is to be able to combine those two queries, and we will call that a subquery. So we're going to have a main query where we're going to select something, and then we're going to have the subsidiary or secondary query, which is going to go in parentheses, sort of like that, and we will see how we put those two parts together. That's the main focus of our lecture today. And then the third one that I want to show you right at the end is called a SelfJoin. We can actually, believe it or not, join a table to itself. Now this is a rarer form, and I'll explain at the end of the video why we don't do this so much anymore, but I think it's pretty cool, and I just want to show you that it's possible. All right, well, let's start out with this notion of the simple subquery. We're going to look at this question, and we're actually going to answer this query in three different ways. It's which birds have been seen by the person who saw a brown-headed cowbird. Now, I cheated a little bit. I know there's only one, but that's okay. We're going to answer this in three different ways. We're going to do this right here as two queries. Then I'm going to combine it into a subquery. And then when we get to the end of the lecture today, I'm actually going to do it as a self-join, just so that you can see what it is. So we're going to be familiar with this one by the time we get to the end. All right. So the idea, if I do this as two independent queries, the first thing I need to know is actually the back end of that question. I need to know who saw the cowbird. And once I answer that question, I will have a person ID, for example. Then I can go back and I can ask the second query, which is, which are the birds that that person has seen? Well, by themselves, neither one of these queries is difficult. We can do both of them very easily. So here is the query to find out who saw a cow. Again, I know there's only one person because I cheated, and I cheated again here a little bit too. I just looked up that the cowbird's ID is 12. That's out of the bird table. Now, could I have written this to reach out to the bird table. Yeah, I could have made a multiple table query here, but I'm just trying to be as simple as possible. So who saw cowbird? It's person ID number 17, right? Select the foreign key person ID from the sighting table where the foreign key bird is 12. Well, there's only one. It's person number 17. Who is that? Well, I don't know. We could go look it up. So then I take that and I put that in my second query. Now I'm going to do a multiple table query. I want to know all the common names of the birds where the person ID in the sighting table is 17, and I want to accumulate or grab all of the bird foreign keys, and those are the cowbird and a sparrow and a raven. So there's only 3 birds, but I can put those two. I take that ID number 17, and that gets me to my answer of my question, which birds have been seen. So that's how I would do that as a 2-query system. Now here's the trick. The first query gives me an answer, which is ID number 17, and I manually put ID number 17 into the second query. So the thing we're trying to do now is to combine these 2 queries so that we don't have to do this manual copy, paste, or retype. So here's what I'm going to do. I want to take out of query number 2 on the right, I want to remove the number 17. And what I would like to do is to replace it with query number 1, which is how the database gave me answer number 17 to begin with, right? So as I write this query, I am going to combine them together into one, and it will give me the right answer, and you'll see the structure here that I'm working with. Now, the one thing you'll notice immediately is that I've got parentheses down here, and those are really, really crucial. I must put parentheses around my subquery. Otherwise, MySQL can't figure out the relationship between this query, my subquery, and the one in yellow here, which I'm going to call the main query. So I always need to have those parentheses there. And all I need to do is paste inside those parentheses that first query that was on the left-hand side. Believe it or not, I'm done. Now you'll notice that I also indent the subquery a little bit, and if I can, and especially if I'm working in a text editor, I always like to indent that because it shows me the relationship between those 2 parts. And you'll notice too that I still have a semicolon at the end. I can't forego the semicolon, right? All right, now that top part I always think of as that main query, and the bottom part I think of as the subquery, and I think that's a pretty common terminology. So as we're going through, if I refer to the main query, that's the big one. And you'll notice the main query is always the one that's answering the question, right? So the question we were looking at is, which birds, blah, 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 blah. And you can see I'm selecting bird.common. So I am answering the main question, or the first part of the question, with that query. The second part, or the subquery, is the back end of my question, like who the heck saw that cowbird, right? When did New York join the US? Who won all the Super Bowls, right? All of those questions are going at the end. Now, again, I just want to remind you that so far we've done this one query in 2 different ways. I did it as a 2-query set. We've just done it as a subquery. And just a reminder, I'm going to come back to this at the very, very end of the lecture, and then we're going to do it as a self-join. So we'll do this in a 3rd way. Well, let's flip over to the terminal window, and we'll do a version of this just so we can practice a bit. All right, here in the terminal window, I have just gotten into MySQL. And now, of course, we need to use Bird Club. We need to use the proper database. So there we go. Now, I think the practice query that I would like to do is to, I can't think and talk at the same time. Okay, let's do this. What I would like to do is to see all of the birds that have been identified or seen by Bird Club members who don't have a phone number. So if I do select star from person where phone is null, now I get to see all of those people. So which are the birds that have been seen by those people? Great. 2-part query. Number 1, do what I just did, figure out who those people are. get their IDs, and then I can go back to the sighting table and I can identify those birds. Once I have those rows, I can go from the sighting table to the bird table and get the common name. Perfect. No problem. All right. So here at the top, I've just taken the liberty to type out that query. So you can see it's 8 rows long. So, we're getting to bigger queries now. So what I'd like to do is to select the bird.common. And obviously I need to reach across all 3 tables, right? So I need the person ID of everyone who has no phone number. From the person ID, I can go to the sighting table and get all of the birds that they've seen, all the foreign keys. Once I have the bird foreign keys from the sighting table, I leap over to the bird table and retrieve the common name. So my where clause is what we've seen all of the way through in a multiple table query. So I'm jumping islands in the stream, right? And so if I think of the person table and then the sighting table on the left and the sighting table in the middle, then I'm going from the primary key in person to the foreign key person in sighting, and I'm also going from the foreign key bird in sighting all the way over to the right, if I imagine it on the right, to the primary key of the bird table. The only extra criterion I have is that I need the person ID to be one of these guys, right? Because I need to know whose phone number is null. So this is the question that I just said. It's almost a select star. I'm selecting the ID from the person table where the value in the phone column is null, right? Great. Now maybe you can predict what's about to happen, and that's okay. So all I'm going to do is I'm going to copy that. I'm going to come over and I'm just going to paste it into the shell. There we go. And I get an error. And this makes sense, right? Because this is why I did this first. So the subquery returns more than one row. Well, what's the problem? Well, the problem is this. Equals assumes that I'm only going to give it one item. But in this case, I'm actually giving it 4. So, and we may not have talked about this necessarily earlier in the term. I can actually use the in keyword to give MySQL a set. So I can say something like select star from person where ID is in 3, 2, 5, and 8, something like that. And so I get 2, 3, 5, and 8. So I can give MySQL the keyword in followed by a set of values, and that's totally legit. That is the clue to solving this error. So I have rewritten the query here in exactly the same way. It's just that I removed the equal sign and I put the keyword in right there. So this now will be person ID in, here are my people, 3, 8, 12, and 17. So my subquery is going to provide 4 rows, 4 IDs that MySQL will treat as a set. Right? Perfect. Okay. Well, let's give it a shot. So I'm going to come in, I'm going to copy that, I'm going to come over here, and I'm just going to go into my shell, and I'm going to paste. Yeah. Perfect. There we go. So these are the birds. There are 8 of them. So those 4 people who have not given us a phone number have seen these birds. All right, let's repeat the process, but this time let's have a slightly more sophisticated subquery. This time we'll use an aggregation where we need to count something up. So let's tackle this question. Which birds have been seen by the person who saw the most Baltimore Orioles? So again, it's a 2-part question, and in this one, we need to make 2 passes through the sighting table, right, to answer both of those questions. So first, I need to figure out who saw the most Orioles. And so what I need to do is to write an aggregation query, right? I need to group by the person, and then I need to do a count, and then I need to figure out who wins. So I'm going to write that query. Now, if you haven't watched the previous lecture on aggregation and grouping and counting, etc., this might not make sense. Go back and watch that video first and then come back. Now, I'm just going to cut to the chase. I'm going to cheat a little bit. The answer is Robert Smith. He's person ID 1. I already looked that up. But notice, in this version of the citing table that I have on the right here, I must look through every single row of the citing table in order to figure out who wins. Only 2 people have seen a Baltimore Oriole. And in fact, I must look all the way to the end, to the very, very, very last row in order to make sure that Robert Smith is the one who's going to win that contest, right? So this is one full pass all the way through the citing table just to identify who's won. And now that I know that that's Robert, I can start over. My second question or my second query goes through the citing table again, collecting all of the birds that he saw. Now, you'll notice 3 out of the top 4 rows belong to him. But until I answer question 1, I don't know that the first 2 rows in this table are things I need to be counting. So that's why I have to make 2 passes through here. But again, it's the same idea. I just write those queries separately and then I can combine them into one. I went pitch black here for the background. So here's the first question I need to answer. Like, who has seen the most Orioles? Now, this is a group by, I'm ordering, etc. So I'm doing all of the lessons that we learned doing aggregations earlier, right? So I want to select the person ID where the common name of the bird is the Baltimore Oriole. So I'm not cheating on that ID. I'm actually going and retrieving that ID. And then what I'm doing is I'm grouping by the person ID, the foreign key there. And I'm doing that because my question is, who's the person? So when I group, I must group by some identity of the person. And then I'm ordering by the count of star descending. Now remember, star means everything, but depending on the context, the definition of star might change a little bit. So if I leave it in the select clause, for example, it kind of means like all rows. But down here, it means count the number of rows in each group. So it's a slightly different meaning. So remember that star changes its meaning subtly depending on the context. So I'm counting the number of rows in each group. I'm having MySQL order them by count descending. That means that the top one is the most. And so now my limit 1 clause or my limit 1 phrase at the end just takes the top person, right? No problem. All right, and here we know that's number 1. So person ID 1 is Robert Smith. So we need now to take this ID and put it back into the main query, which looks like this. Again, I want to know the birds that Robert has seen. So I'm selecting the common names of the birds. I'm reconciling the foreign keys. But in the citing table, the foreign key for the person must be 1. And so here are the birds that Robert has seen. You'll notice the Oriole is on there twice. So I could remove those duplicates if I wanted to. Right. Again, same process. That foreign key will be replaced by the entire query that we just did to find it, right? So in the bigger scheme of things, this is what that's going to look like. Again, my main clause is up at the top, and I have just simply removed the number 1. I put in my brackets or my parentheses for a subquery, and I paste the entire query right in there, just like that. No problem. Again, this one's more complicated. In fact, the subquery is more complicated than the main query, but that's totally fine. That doesn't bother us a bit, right? And again, we saw this just a minute ago. I am assuming that I'm going to have one person, and in fact, my question was phrased like that, right? Who is the one person who's seen the most Baltimore Orioles? And then show me all of the other birds that person has seen. So I am doing a limit 1 here, and that's why That equal sign is up there now. Could I put it in for the equal sign? I sure could. That's fine. It's just going to be a set of 1, so that is totally fine. But as we were just doing in the terminal window a moment ago, let's ask a slightly different question here that will give us a set rather than one person. So let's look at this one. Let's see all of the birds seen by all of the people who have seen a common raven. So I just changed this query slightly. And if you work from the bottom up, you'll see that I replaced Baltimore Oriole with common raven, which is here in white. And I've replaced the equal sign with in. Again, because the in keyword means that a set will follow. Now, how many of those guys are there? Well, I just cheated just in case you're curious. There's only 2. It's Bob Smith and Cody Allen, but it doesn't matter. Okay. And then the last thing that I did was I put the distinct keyword up in the select clause. And the reason I did that is because there's a lot of overlap between the birds that these 2 guys have seen. So, for example, both of them have seen a common raven, so that's going to show up at least twice. And I think you can do this without distinct. I think the grackle shows up like 4 or 5 times. It's crazy. It's bonkers. So I wanted to remove the duplicates from the list of birds. And so the distinct keyword does that, right? So just list the species of birds seen by the people who have seen a raven. There they are. That's a more intuitive answer than if you see magpie, magpie, raven, 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 blackbird, blackbird, cowbird, right, et cetera, et cetera. So, so just having the distinct words or the distinct birds there helps a lot. All right, let's look at a different kind of query now. One of the lectures that we did before was a left join, and a left join is the classic query that gives us missing information. So can we use a subquery with a left join? Yeah. Yes. you probably weren't worried about that. But so just as a quick review, here's what the left join does. So if I want to see the list of birds that no one in Bird Club has seen, I do this arrangement. So I take a master list of something. In this case, it's all the birds that we know of. And I subtract from that table the birds in the sighting table that we have seen. And so what I get left over is all of the birds that we have not seen, right? So if you think about it as a little mathematical equation, right, what we're going to end up with on the left is the birds we haven't seen, because we're going to take all of the birds in the yellow and we're going to subtract all of the birds that we have seen. That's the whole sighting table right now. Okay, that's a clue. The whole sighting table. We subtract every bird in the sighting table. And what we're left with is a subset of the master list of birds that are, and we haven't seen. And so we throw away the sighting table, and here we're left with birds we haven't seen. Right. All right. If that doesn't make sense, go back and look at the left join video. It'll become much more clear. All right. Well, let's try a slightly different question. Now I want to know all of the birds that Robert Smith has not seen. So it's not birds no one has seen. It's just the birds that Robert Smith has not seen. Well, the structure of the left join is the same. So I still start with a master list of birds on the left. But this time, the table on the right is not the entire sighting table. It's a subset. It's just the birds that Robert has seen. So I'm going to select all of those records where the person ID is Robert's. And so you can see the little equation down here at the bottom. What I'm going to be left with is a set of birds that Robert has not seen. And how I achieve that is I take the list of all the birds, but then I subtract the ones that he has seen. Right? Makes sense. All right, so can we do that in a left join? We sure can. In this case, the subset of the sighting table is simply select star from sighting where the person ID is 1, right? Those are all the birds Robert has seen. I think there's, maybe 6 of them maybe. So we're dropping a lot of rows. Okay? We're eliminating a lot of rows, but that's fine. So now you can see what's going to happen. we're going to have bird left join a subquery, right? So let's talk our way through that. Here's the classic left join, just for review. Again, you can go back and watch the whole video. But what I'm going to do is I want to select the bird.common. And now remember, we have to write kind of more Queen's English SQL. So I have to say that I'm using the bird table left join the citing table. And that tells MySQL how to join or how to overlap those two sets. The on clause is how to align those two tables. So the primary key of the bird on the left matches the foreign key of the bird ID on the right. And again, to find or to subtract all of the rows that I don't want, I need to identify those rows where some value in the citing table is null. Now, if you remember from the left join video, all of the values from the right table are going to be null. So I have my choice there. But it's common to just select that foreign key. So I'm going to select rows where the bird foreign key in the citing table happens to be null. And that will give me all of the birds we haven't seen. Well, you can see what's going to happen next, right? I need to replace the citing table as a whole with a set or a subquery, right? So here's what I'm going to do. Here's the framework. Everything is all the same, except now I'm going to pretend that I have a table called Rob's birds that are just his sightings. So now I need to replace the name of the citing table with this new one, Rob's birds. So if you think about it, I'm selecting bird.common from bird left join Rob's birds, where the primary key on the left equals the foreign key in Rob's birds, and some field in Rob's birds happens to be null. That's exactly the structure of the left join. Well, how do I get Rob's birds? Well, that one's pretty easy, right? I'm going to select star from the citing table. That gives me every column where the person ID happens to be 1. Now, we remember that every time I ask MySQL a question, MySQL answers in the form of a table. So select star from citing where person ID equals 1 is actually a table. It's temporary. It exists only for the purpose of this query, and then it goes away. But what I'm doing is I'm giving that table a temporary name. I'm calling it Rob's birds. And that allows me to identify columns on Rob's birds so that I can complete the left join query. All right, let's take this one out for a test drive in the terminal window. So you don't have to suffer through watching me type so much. I already typed this one out. This is exactly the query we were just working on. So this is a left join. So you'll notice, obviously, I'm selecting from citing, but I'm aliasing the answer, or that subset, as Rob's birds. And that allows me in the on clause and the where clause to refer to specific columns on that table. So I'm just going to do this on the keyboard so it's taking a little longer. I'm going to copy that. We'll move over. I'm still in bird club, and so I'm just going to paste that query. Here we go. So here then, 14 birds. Sorry, I'll scroll up a little bit. 14 birds that Robert has not seen. One last technique. SelfJoin. So here's our old friend. This is the query we started with today. We've seen it twice. Here's the third time. Which birds have been seen by the person who saw the brown-headed cowbird? So again, we do it in 2 steps. We have to look in the citing table to see who saw the brown-headed cowbird, and then we go through the citing table again to see which other birds they've seen. So we make 2 passes through the citing table, right? So, well, think about that. Here's the first one, right? So the main query is referring to the citing table, and that's going to give us all of the birds. But there was another one we're referring to the citing table in the subquery as well. Now it's almost as if those are 2 different tables. They just accidentally happen to have the same name. Well, what if that were true? What if we had a copy, an exact copy of the citing table and could treat it differently? What would that mean? Well, it's interesting because if we did have two copies of the citing table, then we could do this like a normal join, a normal inner join. And in fact, we wouldn't need the subquery at all. So let's talk our way through how that would work. The query then would look something like this. I'm going to select the common name of the bird from the following tables: the bird table and the citing table and the citing table, where the following criteria are true, blah, 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 right? All of that sort of stuff. And I know this looks weird, but it's nothing we haven't seen before, right? So I'm going to use one copy of the citing table to answer the question, who saw the cowbird? And I'm going to use the second copy of the citing table to answer the question, which birds were seen by that person, mystery person X. So that's how I'm going to work that. I was thinking about that as a diagram. Since the very beginning when we started doing multiple table queries, we've always thought about these tables as an overlapping Venn diagram. And we've always called these, well, so far, inner joins. We know that the left join is a kind of an outer, etc. Okay, yeah, we can go back and watch that video. So we're just doing an inner join with three tables. We've done this before. We did the bird table and the citing table and the person table. So we have done these three table inner joins before. In this case, I just want to use the citing table for both of the others. So I'm going to do an inner join between bird and a citing table and a citing table. And again, one of them, I'm going to use one of the citing tables to answer the question, which person saw the cowbird? And I'm going to use the other citing table to say, what are all the birds seen by person X? No problem. Here's the dilemma that you already have noticed. How can MySQL tell the difference between the two citing tables if they have the same name? And the answer is, well, of course it can't. But we know how to alias a table. We just did it when we were working with the left join. So we're going to do the same thing. And this is the mystery trick. Well, that's not really a mystery. So if I say I want to use the citing table and I give it an alias as, I'm going to call it citing 1 or S1, then MySQL makes a copy of it and it calls it a different name. It gives it the name S1. And I can say, now take the citing table, make a copy of it, but name that copy citing 2 or S2. I'm using a short version because I'm lazy and I don't want to type all that out, right? And I could have 3 or 4 or 5 or 6. It doesn't really matter. MySQL can make as many copies of this table as it wants to. They don't all exist on the hard drive, but they just exist in memory. And we've seen that before all the time too, right? Like every time we ask MySQL a question, it answers in the form of a table, always, the whole time. So this is just a variation on a theme that we've already seen. And in fact, I'm not going to go too far down the rabbit hole in this one, but here's the query. And so I'm selecting the bird.common from 3 tables, from bird and citing. But you'll notice here that I'm aliasing one of the citing tables as S1, and I'm aliasing the other one as S2. Now you can imagine, right, citing table 2 is the one that was in the diagram on the bottom right. And in that one, I'm asking to find out all the rows where the bird ID is 12. That's the cowbird. So in that bottom right citing table, I'm saying, give me all the rows that belong to a cowbird. Once I have those rows, I'm using the keys to cross the islands of the stream, as it were. I'm moving from the bottom right-hand citing table 2 to the citing table 1, which was at the top. The keys are exactly identical. I'm moving from the person key in citing 2 to the person key in citing 1. Now, once I'm on citing table 1, I retrieve all the bird IDs from that person. And then lastly, of course, at the top, I jump from the citing table foreign key to the bird primary key, and I give the bird.common. So I get exactly the same answer we've gotten twice before. It's just that this time I'm using this other technique called a SelfJoin, and I don't need a subquery in order to do this. Well, why do we have this technique? Well, the answer is that this is yet one more way that we can write this kind of two-step query. But in the olden days, and it's really like MySQL version 5, and around there, people who've been around for a long time, MySQL actually couldn't do subqueries back then. So all of the old veterans, like crusty veterans like me, we got a lot of practice writing SelfJoins because we couldn't do subqueries. So there's still something really, I think, quite elegant about a well-crafted SelfJoin. But again, it's the same idea. The gist is that because I have to make two passes through the citing table, I'm just going to pretend that they're different. I'm going to pretend that there is a copy of a citing table and there's another copy of the citing table. They have different names, and I'm just going to treat them as if there's wholly different tables. And I'm going to ask one question of each of those tables. And so I can do that by aliasing, as we see here. I'm not going to do this in the terminal window, but if you want to go ahead and practice these, you can. You may not see as many SelfJoins around anymore, but I think they're quite nifty, and they're very kind of postmodernly elegant. You want to think about it. That's maybe going too far. Be it as it may. All right, well, that's all we've got for subqueries. Again, they're ways to take what seems to be like two questions and to fold them into one query. And as you've seen, we've got a variety of different techniques that we can use to do that. All right, well, thanks very much, and good luck with your subqueries.